I love my fish. But wait, what's up with my fish? Uh, it seems to be swimming all right, but it won't go down, not even if I push it. And hey, what's up with that one? It seems to be stuck down at the bottom. Even if I lift it up, it falls straight down. This one's stuck at the bottom, and that one's stuck at the top. Dude, what's up with my fish? Maybe I need to learn something about sinking and floating. Hey Heather, can you help me out?
Today we're going to learn about how some objects sink and some objects float. The reason that things sink or float depends on something called density. Density is how much something weighs, its mass, compared to its volume, how much space it takes up. So let's look at some examples. Here we have 3 balls. They all have the same volume, they all take up the same amount of space, but they all have different mass. They all weigh something different. This one is filled with air, this one's filled with water, and this one's filled with salt. Let's make sure that they all weigh differently. The one filled with air weighs 55 grams. The one filled with water weighs 451 grams. And the one filled with salt weighs 654 grams. This means these 3 balls, although they have the same volume, have different densities. So let's see what happens if we put them in the water. The one filled with air stays on top of the surface. It floats. This means the density of this ball is less than the density of the water that it's sitting in. So even if we try to force it down below the surface, it comes right back up. The ball that's filled with water has the same density as the rest of the water. So what happens is neither sinking nor floating. It stays in the same position all the time. And the one filled with salts, although it has the same volume as the other 2, has more mass and is more dense than this water. So it sinks straight to the bottom.
As you can see, some materials float and others sink. By combining different materials, engineers can design vehicles, like boats or submarines, that float or sink as they want. There are 2 basic ways of controlling buoyancy. The first is by controlling the balance of materials that float with those that sink. For instance, if I were to notice that 1 pen cap plus 1, 2, 3 paper clips would float, but that 1 pen cap plus 4 paper clips would sink, then I could simply design a device to remove 1 paper clip at the bottom such that I could go down with 4 paper clips, remove 1 paper clip, and go up with 3 paper clips. Another way of controlling buoyancy is to control the materials themselves. For example, we already know that 1 pen cap plus 3 paper clips will float. But if we put it in this bottle and close the lid, we can actually make it sink simply by squeezing the bottle. Taking a closer look at this experiment, you can see that the air inside the pen cap gets squeezed too. This increases the density of the air and makes it sink. Releasing the pressure makes it float. Increasing the pressure makes it sink. Fish use an organ in their body called a swim bladder to control their position in the water. By expanding or contracting this organ, fish can float or sink. It turns out that my fish had a problem with their swim bladders. One was too big, and the other was too small. Fortunately, this is a fairly common problem, and my vet was able to fix it. Now my fish and I are happy just like before. So, we've learned some basic things about sinking and floating. But please, join us for part 2, where we will explore how engineers and scientists use this knowledge to design vehicles and explore cool places like the ocean.